Have you ever had something happen to you that just can't be true? Imagine you travel to Antarctica, but find a warm oasis there bursting with green vegetation. Or, on the contrary, imagine the Sahara Desert suddenly becoming covered with ice, while the climate remains the same everywhere else on Earth. Or imagine your pet hamster suddenly gets smarter in a month, becomes a scientist and defends a thesis in physics. Well, not only your hamster, but every hamster on the planet. You'd say that can't be. It's just nonsense, it's not even funny. But there were 3 events in history of our planet that suggest just such absurd parallels. Today, you're going to learn, why was the sun cold and the Earth warm in ancient times? What evidence indicates that Earth once was completely ice-covered, up to the equator? Why do we know almost nothing about life on Earth earlier than 500 million years ago? And what made Darwin doubt his theory of evolution? 3 mysteries of the Earth's history. Please like this video and subscribe to our channel. This way, YouTube will know what kind of videos you like and will show you more similar content. Life on Earth began about 4 billion years ago. Imagine that there was an intelligent advanced civilization somewhere in a neighbouring star system on an Earth-like planet. And scientists there were watching our solar system through a super powerful telescope. Once they'd spotted a third planet, our Earth, they'd probably get excited. They'd think it was a similar world. But no, they would surely conclude that our Earth is not suitable for the emergence of life at all, because by all accounts, it would clearly be beyond the habitable zone. As a reminder, the habitable zone is a range of orbits around a star where a planet can have liquid water. That is, far enough away from the star so that all the water doesn't evaporate, and close enough so that it doesn't freeze. Liquid water is an essential condition for life to exist. So why would alien astronomers consider Earth to be outside this zone of life? Because after comparing the sun's luminosity and the distance to Earth, they would have had to thought that our young planet must be a lifeless, icy desert. And guess what is the most important thing in all this? They'd be right. 4 billion years ago, our sun was shining 30% less brightly than it does today. If the sun was to suddenly reduce its power to that level today, the Earth would certainly freeze completely. So are scientists wrong then? Did life arise much later? No. We know for sure that life arose on our planet at that time, or even earlier. And we know for sure that Earth had plenty of liquid water back then. And it wasn't under a kilometre-thick layer of ice. It was right on top of the surface. Moreover, we know that Mars had roughly the same conditions, and it was even farther from the Sun and receives less light from heat from our star. Something doesn't fit. Where is the mistake? There is no mistake. The Sun was indeed cold and the climate on Earth was indeed quite warm. It's not a mistake. It's a paradox. In the scientific community, it's called the faint young sun paradox. The legendary astronomer Carl Sagan was the first to pay serious attention to this paradox in 1973, and at that time he and his colleague George Mullen suggested versions of solving this puzzle. Other scientists followed them, and the paradox began to quickly gather hypotheses. Yes, there were many of them, because none of them gave an exhaustive answer. Let's consider the most viable and plausible ones, and then see how this scientific search ended. One of these hypotheses says that the ancient Earth was warmed up by the moon. Of course, it doesn't mean that the moon at that time was not only shining, but also was warming. The point is that our satellite then was much closer to the Earth. During its formation, 4.5 billion years ago, the moon was only 22,500 kilometers away from the Earth. This is 20 times closer than now. Astonishingly, this is twice as close as the height at which geostationary satellites circle now. Since then, the moon has been continuously moving away from Earth at a rate of 3.78 centimeters per year. about the same speed as our fingernails grow. And at the time of the emergence of life on Earth, it would have moved away only about 20,000 kilometers. So at such a close distance, the tidal influence on our planet was much stronger. Let's remind you that we observe tides because the moon, by its gravity, attracts huge masses of water in the ocean, which causes the water to recede from the shores and then go back. But the thing is that the moon attracts not only water, but also other things. Plains, hills, mountains, and Earth's bowels. It's just that water is movable and there's a lot of it, so we see this process clearly at the interface between the oceans and the land. And there are also stresses and deformations in solid rocks. They're invisible to the eye, but they cause heating due to friction. In the era of the young solar system, this heating could well add a few degrees to the temperature of the Earth's surface. But it turned out pretty soon that the tidal forces alone wouldn't have been enough to compensate for the cold young sun. From this hypothesis grew another. Why do we think that the distance from the Earth to the Sun 4 billion years ago was the same as it is now? This thought is inspired by the analogy with the proximity of the Moon to the Earth in those ancient times. This option was also considered by scientists, however, it didn't hold water, rather. But even if we assume this option to be true, this hypothesis still contradicts the fact that Mars also had a mild climate. Mars would have been too far away to maintain water in liquid form anyway. Yet, the red planet had a whole ocean the size of the Earth's Arctic Ocean splashing around back then. And actually, 3.5 billion years ago, Mars reached the peak of development of its hydrosphere. So this version doesn't fit in any way. Another version suggested that although the sun was colder at that time, its activity was higher. And there's no contradiction here. It means that the sun's luminosity was 30% lower than it is today, but it was losing matter at a faster rate. Frequent solar flares created a more powerful solar wind than we have today. And the solar wind is a stream of particles, not light. It's known for sure that the sun has lost about 5 to 6% of its mass during its existence due to these processes. Therefore, it's quite likely that these fluxes of high-energy particles could have contributed to the heating of the planet. Nonetheless, this too was still insufficient to adequately heat the Earth and Mars on top of that. Desperate scientists came up with ever-new theories, sometimes quite exotic. From cosmic rays to the Gaia hypothesis, the latter is something special which already lies almost on the verge of mysticism. So, according to the Gaia hypothesis, our planet is a huge, single, conditional superorganism. And in this organism, all living and non-living things form a complex system that is able to self-regulate, to change the conditions to create the most favorable climate for itself. The theory may sound too romantic, but it was proposed by an absolutely sane man, James Ephraim Lovelock. He is an English independent scientist, MD, professor, environmentalist, and futurist. In addition, he is a Knight Commander of the Order of the British Empire and the Order of the Companions of Honour, a member of the Royal Society of London, and a winner of various awards. However, despite all the regalia of James Lovelock, the Gaia hypothesis was criticised as intractable. So what did the scientists agree on? As it is often the case, the most plausible hypothesis at the moment is the most obvious and trivial one: the greenhouse effect. Yes, the very greenhouse gases that now make environmentalists worry in those distant cold times served as a warm blanket for the Earth. Most likely, the Earth's atmosphere retained much more solar energy than it lost, which resulted in a mild climate. This hypothesis can also explain a similar situation on Mars, where volcanic activity was still in full swing at the time, and therefore there was no shortage of greenhouse gases. Of course, other versions cannot be completely ruled out, but most likely they served only as a supplement to the main factor. And there's another twist to this story. If the sun had been brighter and warmer back then, the Earth would probably not have been doing so well. The point is that greenhouse gases would have formed anyway, because volcanic activity wouldn't have disappeared. And with a brighter sun, the temperature would rise to the point of no return. All the oceans would have evaporated, irreversible processes would have started, and instead of a green-blue paradise, Earth would now be a poisonous, yellow, acidic hell like Venus. We all came into being thanks to a faint young sun. There is something we haven't told you in this story. There was a period in the history of Earth when it froze over. And no, we're not talking about the Ice Ages, because those were just localized cold spells that still left many areas with temperate climates. We're talking about real global icing, which turned our planet into one giant snowball. During it, even the tropics were iced over, even the equator. There's a serious hypothesis that this has happened to our planet, and even more than once. The hypothesis is called Snowball Earth. This raises three questions. Why did the Earth freeze? How and when? How did it thaw back? And when can it happen again? Let's try to address each of these questions in sequence. So, why did the Earth freeze over? Let us say once again that this is still a hypothesis. It has both supporters and skeptics. But even the supporters must have figured it out somehow. How? This discovery was pursued by different scientists at different times. The fact that the Earth underwent a total freeze was directly indicated by several geological findings in the 19th century. The first one was made in 1871 in Islay, Scotland, when tillite, very ancient sedimentary materials of glacial origin, were discovered. Similar finds were reported in the same years in Australia, India, Norway, and practically all over the world. But at the time, scientists lacked other pieces of the puzzle to realize that they were dealing not with just signs of some scattered glaciers, but with the evidence of something dreadful in Earth's history. The fact that the hypothesis of the continental drift was not yet recognized at the time also hindered this realization. But then, when it came clear that the continents are moving, and with quite measurable speed, scientists were surprised. It turned out that many locations where tillites were found at the time of their formation were in tropical zones or even on the equator. That is, it appeared that the warmest region of the globe was once frozen over. They began to check and everything matched. They tried to calculate the possible temperature, and opinions varied. But according to some versions, it appeared that even near the equator, the temperature could have dropped to -50 degrees Celsius. So it's even hard to imagine what was happening on the poles. Thus, the hypothesis was gradually developed, and the term snowball was proposed in 1992 by Joseph L. Kirchvink, an American geologist and geophysicist from the California Institute of Technology. Furthermore, more scientists started to study the issue because it was clearly something new and important. They even calculated the approximate period when the Earth experienced this icy catastrophe. It turned out that it happened at least 3 times. In the Paleo-Proterozoic era, about 2.4 to 2.1 billion years ago, the Huronian glaciation occurred, the longest and most extensive glaciation in Earth's history, and perhaps the most mysterious one. Much later in the Neo-Proterozoic era, the Sturtian glaciation took place about 707 to 660 million years ago. And almost immediately after a short break in 10 million years, the Earth was hit by the third great glaciation, called the Marinoan glaciation, 650 to 635 million years ago. It was relatively easy to calculate the ages of the glaciations. Their causes were much more difficult to determine. And even the very mechanism of these processes wasn't quite clear. How did it happen that a planet with quite a mild climate, an already formed life, suddenly freezes to such an extent that it becomes similar to Saturn's satellite Enceladus? There was a rather bold theory that the tilt of the Earth's axis, now at 23.44 degrees, would have increased sharply due to a collision with a large asteroid and then gradually leveled off. Gradually means millions of years of glaciation. In such a case, most of the planet could theoretically have been in shadow, and much of the sunlight would have passed tangentially, not really warming the planet. Hydrological cycles, i.e. the water cycle in nature, would certainly have been completely disrupted as well. Let us clarify this point. This scenario may seem implausible because the planet would have remained at the same distance from the Sun anyway. So it shouldn't matter what its axis tilt would be, right? But in fact, it all could very well happen because of the tilt. Planetary scientist Russell Dietrich and his colleagues have published a paper in the Astronomical Journal that conclusively proves this. However, although this epic version is worthy of a Hollywood movie, it is the weakest in terms of feasibility in the case of the Earth. Not even traces of a crater of the corresponding size has been found. This is first of all. And secondly, how can we then explain the two other glaciations? Less movie-like, but still epic hypothesis suggests a one-time passage of the Earth through an interstellar cloud of large cosmic dust. Mixing with soot and volcanic ash, this dust could have increased the albedo. Example, the reflectivity of our planet's upper atmosphere. In this case, some of the Sun's energy would have been scattered in the upper layers, not reaching the surface, and some would have been reflected. This scenario, by the way, is not fantastic. Giant cosmic dust clouds remain after supernova explosions. One such cloud formed our entire solar system, and some small fragments of ancient stars drift in the vast universe. Well, small is a relative term. This hypothesis claims that the complete passage of the solar system through such a cloud could have taken about 500,000 years. But again, this could explain not more than one event of freezing of the Earth into a planetary snowball. But 3 times is obviously too much. Besides, we don't find on our planet traces of an ominously young uranium-235 and other heavy elements of extraterrestrial origin, which would be a clear sign of such an event. That is, there is simply no evidence to support the hypotheses. And now, finally, comes the most plausible version. It is, as always, the simplest and most obvious one. Greenhouse effect. Again, but how? Yes, it's not a joke. What is now causing concern over global warming may well have once had the opposite effect. Under certain circumstances, an increase in greenhouse gases could lead to the Earth turning not into Venus, but into the aforementioned Enceladus, only bigger. Such a scenario can be illustrated in the example of the most recent glaciation of the late Proterozoic era. It could have been caused by the following sequence of events. In those times, the map of the Earth's continents had little in common with what we have now. Back then, the process of disintegration of the ancient supercontinent Rodinia was in full swing. We had a special video about ancient supercontinents. So the disintegration was accompanied by intense volcanic activity, so that huge volcanic arcs were formed, increasingly saturating the atmosphere with ash and soot. Over time, the atmosphere became less and less transparent to the sun's rays. Eventually, a natural analogue of nuclear winter, or rather nuclear autumn, came when the temperature on the Earth's surface remained around 0 for a long time, or even much lower. Remember that the sun was less bright in the past than it is today. But over time, volcanic activity weakened and the atmosphere began to clear. It would seem that the planet should restore the normal warm climate, right? But no, because the long winter and fall didn't end without a trace. By that time, the albedo, in other words, the reflectivity of the planet's surface, had already increased greatly due to snow-covered plains and even more snow-covered young mountains. And there were fewer and fewer heat-retaining greenhouse gases. Plus, scientists found evidence of excess water vapor in the atmosphere which could have contributed to the increased amount of clouds. And these clouds were white and very low. so they were contributing to the planet's reflectivity. And finally, the ocean. The ice caps at the poles were gradually creeping farther and farther into the ocean. Slowly but surely, chaining of the oceans by snow-white ice plates led to further accelerating growth of albedo. It was a kind of chain reaction. 1. Less greenhouse gases, colder. 2. Colder, more ice. 3. More ice, higher albedo. 4. Higher albedo, even colder. 5. And we're back to the point 2 again. And then again, everything repeats circle-wise. The combination of rising albedo and declining greenhouse gases could have worked as a trigger for irreversible processes that rapidly and permanently cooled the Earth. So in a matter of hundreds of thousands of years, the Earth could have become an endless icy wasteland, with the highest mountain ranges still rising above it and volcanoes still fuming. Did we say permanently? It would seem that there is no way out of this trap. Then how did Earth get out of it? The question is crucial because opponents of the Snowball Earth theory have used this argument. They believe that glaciation on such a scale would be irreversible. Nevertheless, scientists use numerous models to prove that the Earth could still get out of the ice trap on its own. And the same logic works here. As the planet froze and became increasingly covered in ice, the processes of removing carbon dioxide from the atmosphere weakened. While global glaciation continued, our planet's tectonic activity was still taking place. Volcanoes continued to erupt, adding carbon dioxide to the atmosphere. It gradually accumulated there again. The more greenhouse gases accumulated, the higher the temperature became. The ice may have started to thaw, the albedo decreased, and this started the same chain reaction, but in the opposite way. And according to one theory, the Earth was helped out of the latest glaciation by a guest from outer space. No, not an alien, but an asteroid that fell onto the territory of modern Australia. We mentioned this event in one of our previous videos. It could have been the trigger that reversed the cooling chain reaction. Okay, the most plausible version of icing looks really plausible, but there's an unsettling aspect to it. The process looks very cyclic, and if so, could it happen again? Just imagine glaciers as high as the Appalachians returning to temperate latitudes, and the descendants of the last inhabitants of the deserted cities of frozen India, Thailand and equatorial Africa would be left to grieve for the bygone warm era in which their ancestors lived. Can the situation of the Snowball Earth repeat itself? A group of scientists from Peking University tried to answer this question in 2011 and built a special computer model. We're not going to nag you with long suspense. The scientists believe it is likely. The insolation factor is not as significant today as it was billions of years ago. The sun is gradually heating up, and now it's much hotter than it was then. The freezing cycle can be started again only if there is a significant external impact, an asteroid fall or the above-mentioned galactic cloud, or the escape of the Earth from its orbit due to the passage of something massive like a neutron star nearby. But all of this is extremely unlikely, at least in our lifetime. So of the dystopian scenarios, the Venusian one is still the most probable, unless humanity comes to its senses. Yes, a planet-wide catastrophe could be not only cold, but hot. But why should we consider global glaciation as something catastrophic? Well, you might think such a glaciation would have wiped out most of the life on the planet. Yeah, that's right, but here is the thing. What if we say that it was thanks to the latest glaciation on Earth that life as we know it came into being? And we too, as part of this life, appeared thanks to the total glaciation of the planet. At least that's what many scientists believe. And here we come to the third mystery of the Earth's history. What do we know about life on Earth more than 538 million years ago? Almost nothing. All we know is that life was pretty primitive. so primitive that there's almost nothing left of it. But then, 538 million years ago, something happened. Scientists call it the sudden radiation of complex life, because it is from this moment that the vast majority of found fossil remains of living beings date back. Let's emphasize it once again for a better understanding. There are almost no fossils dated earlier than 538 million years ago. Almost all fossil remains of something more complex than unicells are the legacy of the era from 538 million years ago and later. And it seems as if life emerged from nothing at the time. The contrast is really stark. Charles Darwin once called this period the fact which does not fit into the theory of evolution. It is as if someone waved a magic wand in those ancient times and ordered life to blossom into all the diversity we now see around us. This process is so anomalous against the background of the previous, rather dull course of life on Earth, that its dynamics resemble an explosion. That's actually how they named it, the Cambrian explosion. Many scientists were puzzled by this issue. Because the event is a fact, but its causes are so unclear that the scientists didn't even know where to start looking for answers. Yet many researchers eventually found the probable causes of such an anomaly. For example, Francis Crick, the British molecular biologist and Nobel laureate, in his book Life Itself, sets out the following reflections. He suggests that unicellular life must be a relatively simple phenomenon, and the conditions of the ancient Earth were sufficient for its origin and maintenance. But Crick sees no obvious reasons for the evolution of multicellular life, and does not venture to explain why evolution should turn such a complex path as the development of organs and tissues. The scientist suggests that the trigger to multicellularity could have been an ecological catastrophe or another global catalysm. The logic is quite obvious. Life as a whole had to twist and turn to improve to get through the bottleneck of deteriorated conditions due to a planetary catastrophe. And the Snowball Earth fits just perfectly for the role of such a global catastrophic event. At first, scientists were cautious about this hypothesis, but rather quickly it became clear that it all fitted together. In November of 2021, the University of Chicago published an article where the authors directly linked the phenomenon of multicellularity with the Snowball Earth hypothesis. Here's the version of events that it proposed. In the conditions of the Snowball Earth, primitive unicellular prokaryotes could have faced two fundamental challenges. Cold water limited the rate of metabolism in the cell, as well as the mobility of the cells themselves, as well as their cilia and flagella. In addition, the viscosity and salinity of the water must have gradually increased. Both this factor and the saturation of water with carbonates could provoke three major ecological changes. First, the extinction of many taxa of unicellular organisms and hence the vacating of ecological niches. Second, a shift to predation and parasitism. In brief, this is how it could have first happened. A unicellular being swallowed another unicellular being entirely. Yet the prey was not digested, but began to live inside the predatory cell that had swallowed it. So the prey became the parasite. Then such unicellular parasites evolved and even began to bring some benefit to the predatory cell. That's how organelles appeared. And finally, organelles evolved into small cells within the previously unicellular organism. And third, the complication of metabolism, both from the physical point of view, having no filter thick cold liquid, and from the chemical point of view, the composition of brines became diverse and unfamiliar. Of course, the assumption that it was glaciation that caused the Cambrian explosion is not the only one. There are many other theories as well. For example, the aforementioned transition to predation and parasitism is considered by many scientists as an independently developing phenomenon in living nature, separately from the Snowball Earth hypothesis. Other scientists emphasize the decisive role of the emergence of sexual selection. They claim that it turned out to be much more effective than natural selection, thereby accelerating evolution many times over. There are also sound hypotheses of increased calcium content in the oceans, which became a great support for the formation of the first skeleton-like structure of primitive ancient animals. And some see the causes of the Cambrian explosion more abstractly as the overcoming of a certain threshold of complexity, which doesn't have any recognizable reasons. Either way, there is no consensus. The mystery of Earth's history remains a mystery. We know for sure that it happened, but we can't figure out why. And lastly, have you noticed that these three great mysteries of Earth's history are intrinsically connected? It's really thought-provoking.